Unmanned aerial vehicle or UAVs have become essential in modern application, including delivery, surveillance, and emergency services. However, one major limitation to their wider adoption is noise pollution, which not only affects human well-being but also restricts operation in urban environments and near wildlife. Studies have shown that propeller noise can disturb communities, disrupt animal behavior, and reduce overall operational efficiency. At the same time, Malaysia currently ranks first in Southeast Asia in the Drone Readiness Index 2023, reflecting strong national progress in UAV regulation and adoption. This creates a clear demand for sustainable UAV technologies, particularly those that incorporate quieter and more efficient design. In response to this need, the bio-inspired UAV propeller was developed. To create this innovation, we studied the silent flight of owls, the fluid motion of whales, and the drag-reducing skin of shark. From these natural inspirations, we developed a propeller with wave-like edge, fin surface textures, and tiny aerodynamic features. Specifically, the propeller integrates serrated leading edge to disrupt airflow, optimized trailing edge to smooth wake patterns, and boundary layer trips device to manage flow separation. Importantly, this passive modification requires no additional energy, making them particularly suitable for small UAV platforms. Performance evaluation was carried out through computational fluid dynamic simulation as well as psychoacoustic analysis. Comparison between baseline propeller, single feature modification, and double feature configuration were then performed. Testing at various rotational speed allow us to quantify aerodynamic forces, noise levels, and wake structures. Among these, the trailing edge and the combined trailing edge with boundary layer configuration demonstrated the optimum balance between thrust generation and noise reduction. In other words, the design applies principles from owl's wing and marine life while analyzing aerodynamics and aeroacoustics, with further integrates psychoacoustic metric to enhance user-centric performance. As a result, in aerodynamic performance, the bio-inspired propeller achieved an 8% increase in thrust compared to the standard DJI 9450 propeller. In aeroacoustic evaluation, noise levels were reduced by 3 to 6 decibels. Moreover, for psychoacoustic performance, trailing edge configuration recorded most favorable results, delivering optimum balance of loudness, tonality, and annoyance metrics. To ensure robust assessment, a multi-criteria decision analysis framework was implemented to evaluate aerodynamic performance, acoustic footprints, and psychoacoustic comforts. This method guarantees the selection of configuration that provide most balance and optimum results. Beyond performance, the development supports Sustainable Development Goal 9 by promoting industry, innovation, and infrastructure, and Sustainable Development Goal 11 by enabling quieter UAV operation in urban environments and sensitive ecosystems. Consequently, reduced noise level allows UAV deployment in densely populated area for logistics, security, and emergency operation, while in rural area and protected zones, lower acoustic disturbance helps preserve wildlife behavior and biodiversity. Currently, bio-inspired UAV propeller stands at Technology Readiness Level 3, representing a proof of concept validated through computational and experimental studies. According to the Lens org, a total of 132 patents have been issued in last 12 years, indicating the bio-inspired propeller are set to emerge as a key innovation, particularly in improving drone noise performance, because the design offers a unique blend of noise reduction and efficiency is highly attractive to drone manufacturers. In fact, collaboration with industry partner Aeronerv is already supporting the transition from proof of concept to potential market deployment. The findings have been published in index journals including Physics of Fluids, Engineering Research Express, and CFD letters, while additional manuscripts focusing on acoustic perception, structural effects are currently in preparation. To safeguard the innovation, the bio-inspired UAV propeller is registered under copyright, ensuring full intellectual property protection. Finally, this project was made possible through funding by the Ministry of Higher Education Malaysia under Fundamental Research Grant Scheme, with a total allocation of 1,043,860 ringgit. Together, this contribution demonstrates the potential of bio-inspired design to advance UAV technology in sustainable and impactful direction.